Hello students, Dr. Mayathan here, Chapter 7. Chapter 7 talk about solids, liquids and phase changes. At the very first, we look at the solids and how we can classify these solids. It's A showing you solids, but the solids can classify into several groups. Mainly, you can classify solids into amorphous solid and the crystalline solid. Amorphous solid is a solid that molecules are not arranged in an orderly pattern. You can think about plastic. But the crystalline solid, it's like a sodium chloride crystal. They have the atoms arranged in a highly ordered pattern. So some of the solids, crystalline, pure quartz is a crystalline solid, Pyrex glass, soda lime glass. But this you can see there, what are the compositions? The Pyrex we use in the oven, so that's because they have very low thermal expansion. So there are two types of solids, ionic solids and the molecular solids if it is made out of a compound. Most ionic, so if it is an ionic substance, we call it ionic solid, and if it's a molecular substance, we call it as a molecular solid. Atomic solid, it is made out of just atoms. It made out of the array, like an array of just a single atoms. It's atomic solid. And then the network solid is network solid or covalent solid connected by a covalent bond, which is stronger than the ionic bond. So these are the network solids. So the type of crystalline solids, we have the ionic solid, which is ionic bonding, molecular solids, example like bromine, right? HBr. So they in this kind of things, if they're non-polar molecules, they can be polar molecules, or so then these bonds are dispersion forces because it's a interaction with a molecule to another molecule. And then the atomic solid just by atom itself, and the network solids. This is the classification. At the very first, you should see whether the solid made out of element or a compound. Element is just by itself. And then if it is element, if it is the element metal or a non-metal, if it is just the metal, it's the metallic atomic solid. It's a non-metallic atomic solid. And if it is a molecular, then it's going to be a molecular solid. The compound, if a compound is molecular, it is a molecular crystalline solid. It is ionic, it's going to be an ionic solid. So this is mainly the classification. You just need to see what type of solid is that and then just determine the name. So I have given here iron. It's a just made out of atom, right? Iron is just the atom. It's a atomic solid and also it's metallic. Calcium bromide is an ionic compound, so it's going to be an ionic solid. Just I2, it's just by the element itself. Molecular solid, same with sorry, this is the atomic molecular solid, and this is the molecular solid. So you can see, so these are like, so very first what you need to see is whether there's an ionic compound or it's just by atom or it's other any of the molecular or covalent compounds. So so that's about the classification. As long as you know classify some solids, I mean just know what is the ionic solid, what is the metallic solid, you'll be fine. I mean you need to study, do the homework, but you'll be in good shape. And then the next topic we are moving, it is the what are the properties? So we talk about the properties, but at the same time, I want to talk about the physical properties of solids. So the vapor pressure. Vapor pressure is the pressure above the liquid. So if think about your nail polish remover, you can smell it because the the it's acetone. The interaction between acetone molecule is low, so easily the molecule can go to the vapor phase. So vapor pressure is weaker. When the weaker intermolecular forces, more the vapor pressure is high. So I have a question. I'm going to explain you which one has the low vapor pressure. For this kind of a question, I would use the draw the Lewis structure and Lewis structure and see which one has the more attraction, more polar. When the compound is more polar, when there's high electronegativity, compound has higher vapor pressure. So when I draw this one, CH3, I have the CHF3 and then the CS2. You can see this compound is polar. This is non-polar because it's pulling the two sulfides pulling electron in the same strength, but this is polar compound. So this is the overall polarity because fluorine push the electron towards itself, resulting there's a negative and the positive. So this has polarity. Because of this polarity, this has little bit higher vapor pressure than this one. So this has the lowest vapor pressure. Sorry, this one because it has high polarity. This so the vapor pressure because it has high polarity. This has low vapor pressure. This has higher vapor pressure because the intermolecular interaction is low here. So then it can easily go into the vapor phase. So then we talk about one physical property which is vapor pressure and the melting point. Usually solids have the depending on the intermolecular force, they melt at the melting point. And then there are some examples when you see when there's ionic bonds with the ionic solids have higher uh, vapor pressure because you need to bring the ionic bonding. Not like dispersion forces, dipole-dipole interaction, hydrogen bonding. They're weak because they're intermolecular forces, but ionic bonding is strong. So I have these place the following substances increasing melting point. I have lithium chloride. By looking at the lithium chloride, you know it's an ionic solid. This one is the molecular solid, and Cl3 again a molecular solid. So you can see, and also this is chlorine is a non-polar molecule. This is a polar molecule, and so you can see ionic solid has the highest melting point. So you can this has the highest melting point, and then you go to the NCl3 and then chlorine. So this is the order highest melting point lithium chloride, then go to NCl3 and then the smallest melting point for chlorine. Viscosity is the resistance to flow. I mean you can see the engine oil is more thicker than the water, so high resistant. Surface tension is another property. You can see like it's the like little animals can walk on the water body. If you put a paper clip, the paper clip float on the water even though it's made out of metal. That is called surface tension. So that's the mainly the properties, and then the liquid. So we talk about vapor pressure. Vapor pressure is like there's a liquid and then the gas phase. So usually we call it an equilibrium. That means the slowly that think about you have the water bottle and you close the lid and you have half of water. Slowly the water start evaporating from the liquid and go to the vapor phase. But then it slowly that vapor phase saturate, and then the vapor phase start condensing. So if you leave the water bottle and if you leave it overnight, you see at the beginning you don't see any water droplets deposited on the water bottle, but after some time, after like 6 7 hours, you see small water droplets deposited along the bottle because of that condensation. So there's a certain time that condensation and evaporation come to a same rate, At that time, we call it as a dynamic equilibrium. Okay, so that's about the mainly going to do in the part one of the video, and I'm meeting you in the part two.